Studies, a private lecture, The Chemistry of Inequality, Tracing Complex Contaminant Mixtures Across Chile, with the class Luxury scholar, Dr. Carlos Manzano. Just to briefly introduce myself, my name is Andres Cardenas. I'm an assistant professor of epidemiology and pediatrics and for medicine. And I'm really happy to be hosting Carlos for this time, and he's been interacting with our groups, and it's been a pleasure to kind of co-develop some ideas on some projects as well. So just to introduce Dr. Manzano briefly, he's an assistant professor in the Department of Chemistry at the University of Chile and an adjunct assistant professor at San Diego State University Graduate School of Public Health. His work examined how industrial and urban activities reshape the chemical landscape of Chile and other South American regions. His research combines advanced analytical chemistry with concepts from the exposome, and he seeks to understand the mixtures of metals, metalloids, persistent organic pollutants, and newly emerging contaminants like microplastics, and how they affect vulnerable populations and ecosystems. He received his PhD in chemistry from Oregon State University, which is a small world. We actually went to the same school at different career stages, but it's really nice to be able to connect with colleagues here. And then he pursued his postdoctoral research at Environment and Climate Change in Canada, and also at the University of Chile's Center for Environmental Science. His analytical expertise spans gas chromatography, mass spectrometry, atomic absorption spectroscopy, multidimensional separations, and non-targeted analysis, which is really a hot topic right now to try to understand the exosome. At the University of Chile, he leads research that bridges environmental chemistry, human exposure assessment, and data-driven interpretation of complex mixture contaminants. His group aims to connect environmental data with social and policy dimensions, promoting environmental justice and community engagement in regions of South America. His research contributes to a growing understanding of how chemical exposures intersect with health inequalities, providing scientific evidence to inform sustainable transitions and risk reduction strategies. So it's been truly a pleasure to have Dr. Manzano with us for this period of time, and we're really looking forward to kind of develop more ideas with him as well. So please join me in welcoming Dr. Manzano. Thank you.
Thank you, Andres. Thank you for being here, all of you. And thanks to the Center of Latin American Studies for hosting these presentations. It's an honor for me to be here and show you some of the things that we do in the lab in Chile. We call this the chemistry of inequality, basically because we want to use tools from chemistry to first describe and then analyze inequality problems in Chile and other countries in South America. I'm going to be showing data from Chile right now, not including other areas and other places such as Antarctica, because we have tested those methods in Antarctica as well, because we want to know, the limits of this sort of technology we're using and how far they can reach. So first of all, I'm going to show you some facts about Chile. I know you know where Chile is. I'm not going to show up on that, but it has different regions. Very different regions, very dry north. Most of the people from Chile live in the center area of the country where Santiago is, around 8 million people. And the south, the Patagonia, is probably one of the most beautiful places you could ever visit. So go to Chile. Right? The north is where most of the mining industry is happening in this country, and it is a very important industry in the national GDP because, for example, here it has gone from 6%, being 6% of the GDP to almost 15% in less than 30 years. So that's a huge jump. Chile is the #1 copper producer in the world right now, and one of the top producers of lithium, which are two essential elements that are going to be pretty much needed for the next few years, especially with this energy transition we're going through, right? Well, the green energy transition requires some of these metals, and Chile is going to be a big part of that narrative as well. The center of Chile is where this beautiful city is located. Santiago, 8 million people, big city. Is a nice day of winter in this picture. I'm going to show you later a little bit more. And the south, the Patagonia, which is just beautiful. The problem is that all of these regions have also environmental problems that are related to the kind of activities that are going on in these areas. For example, in the north, You do see a lot of mining, and that translates into open pit mining here, or smelting, or just residues from the processing of the mineral that are left there for further processing sometimes. But it's kind of the things that we don't really know what to do with the residues after we recover the copper or the lithium. So you see a lot of these things in the north, and these areas are basically really close to where people live. There are not many people in the north of Chile comparing to the central part, but still you have indigenous communities that are protected under the national law. And that beautiful picture I showed you from Santiago, that picture was after a rain event one day in winter. This is a regular winter day in the city. It is the same city, it is the same landscape. It's just that in winter, this area of the planet has a lot of atmospheric pressure, compressing the atmosphere. So it doesn't leave much space for all the contaminants to just fly away. And most of them are being trapped in the surface part of the atmosphere. So you get this condition, this natural condition, to increase the concentrations of contaminants. Although the emissions might be the same, the concentration that people feel and the people breathe is higher, just because of this atmospheric special condition. And that happens in the south as well. This is the Patagonia. This is what you see in a winter day in Patagonia. The difference here is that you do have higher emissions in winter, because the way people heat their homes and cook is basically burning wood, right? And that produces a lot of contamination, and it's being trapped under these conditions. So this is the country with this special environmental problems. And this is when you see some of these environmental inequality, because the north part has a lot of industry, a lot of production of copper, lithium. You don't see a lot of people there, but the few people that live in this area are very close to where the pollution is being emitted, right? So you start to see some concepts of this environmental inequality. So our goal as chemists is to develop chemistry tools so we can understand better these situations. And we focus first on sample collection, processing analysis to generate this good data that could be used later for other types of analysis. We also look for other chemicals. We're not really interested in the criteria pollutants. We know that these pollutants have been used for several decades, and they are very important to the public health measures that we have today, but we want to explore more. Criteria pollutants are basically atmospheric particles, CO2, carbon dioxide, SO2, sulfur dioxide, right? And we're going to be focusing on organic compounds, which are thousands, tens of thousands of compounds, and metals that are not usually measured in every sample in every city, okay? And we want to focus on less studied areas, not only in Santiago. I'm going to show you some data from Santiago as well, but our main focus is going to be on the north and south, okay? And we use low-cost alternatives, because we don't have a lot of money. First, that's the first reason, but also because we want to increase the spatial coverage. If you have one instrument that is a very expensive and very precise instrument, you can only afford maybe one or two of them. And if you have these low-cost approaches, you can have 10, 20, maybe more, covering a huge amount of space, and you are able to see the differences in that area, right? So if you compare that using one instrument in one city, you're going to have one data, and you're assuming that the whole city is going to behave the same, and the data that you obtain from that instrument is going to reflect everyone living in that area. And it's not the case. You're going to see that it's not the case. So low-cost alternatives are a very good way to increase our information about these areas. And we also want to use citizen science approach, meaning that we're not just going to go there and run away with the data. We want to have people working with us and working for them as well, right? And we actually want them to show us where the environmental problems are, because they live there, they know their places better than us, right? So the first thing I'm going to show is Santiago. That map is not from our research, actually. You can see all these green spaces here. These are green areas in Santiago, and I guess you can easily spot which one is the high income area and the low income area, right? So we're going to use this set of samplers that are personal samplers. These are silicone wristbands. People are going to wear these wristbands for about a week. We usually do 5 days in a week from Monday to Friday because we want to all the contaminants and all the chemicals to be absorbed in the surface of this silicone of this wristband, right? If you want to know more details about that, because there's a lot more details, please talk to me later, and I'll show you what we do. The thing is that these wristbands we were expecting them to absorb a fair amount of compounds. We were never expecting to see over 400 chemicals per person wearing the wristband, right? So what this is showing you is that you have a lot more of these chemicals floating around you. So you're even if you live indoors the whole time, you're exposed to a lot of chemicals. We wanted to know which chemicals these are, and this is a lot comparing to the usually 2 or 3 that are measured in traditional studies. And that plot over here is showing you the x-axis is people that were wearing the wristband, and the y-axis are compounds. So you can't really see this because there are so many of them, but every single line is a different chemical. And the colors right here are showing you the relative concentration of these compounds. So if we look closer, you can see that there are some differences. You see this area, for example, here, showing you a group of chemicals that are present only in these 3 samples, right? And these are people coming from the high income area, right? And what about this here? These are also coming from the high income area in a different time of the year. So there is a pattern here that we can spot, right? If we look into individual compounds, we found a lot of things that are kind of connecting to the lifestyle of people. For example, we see a lot of sunblock creams and products that are being used, especially in the high income area. We see products and chemicals that are used for pets, like Aurelio. Thank you for being here. And these are also most prevalent in the high income areas, right? And if we look into this area over here, you see one really bright spot here, okay? This is caffeine. That is coffee. That is showing you that that person is drinking a lot of coffee. And I know that is true because that was my response. That is real. Okay, so that's showing you the powerful analysis that these wristbands have. I mean, they can show you individual patterns and regional patterns. But because this is so much data, too many variables. Okay, this is weird. Axes are upside down. Anyway, doesn't matter. We decided to group variables. We're not analyzing individual molecules anymore. We're grouping variables into consumer products, combustion products, industrial, natural origin. And we see the differences between the high income areas and low income areas, basically in these 2 bars here, right? This area is this one here. And it is showing you that those 2 particular group of compounds are very different between winter and summer. Summer is the black bar in here, and winter is the red bar. So whenever you see winter, you're being exposed to more chemicals comparing to the other 2 areas. Why is that difference? We're not really sure, to be honest. It could be that winds, for example, are pushing all the contaminants from here to here, might be the case. Or it could be because of the different techniques that they use for heating their homes. If you go to the high income areas, this is all you see. Everything is electric, right? Low emissions. If you go to the low income areas, people are still using fossil fuels for heating. So that is showing you a good measure with numbers of inequality, right? Just because you live in this area, you're being exposed to more contaminants, even if you live in the same city as the other groups, right? So the air pollution, chemical pollution is not uniform in the city. It really depends. It is connected to how people live in the area, and it's connected to these inequalities that we see, right? The uneven distribution of these environmental burdens across people living in the same city. Okay, A few questions came up with this. For example, it's this, you can't really see the bars here, okay? They're not showing up. I was having bar graphics here anyway. The question was that, is this an outdoor or an indoor problem for people living in these houses? And what we try to do here is combine different methods. We use our wristbands and we use a different kind of samplers that are fixed samplers. You put this, you install this in the outside of your homes. And we need to wait for a little bit longer, maybe a couple months. And the thing is that these plots were supposed to show you how different people living in the same house get different exposure profiles. Lines are people wearing wristbands, and the bars that you can't see are the contaminants that were captured with the other technique. So what is showing here very quick, that's another city, okay. What is showing you, what was showing you here, is that, for example, you see different patterns. People living in the same house, they don't have the same pollution problem. They don't see the same distribution of contaminants. It really depends what you do. In this case, for example, this was a person staying indoors the whole time in her house. And this was a person going out to work every day. So living in the same house doesn't guarantee that you're gonna be safe from pollution. It really depends what you do on a daily basis, okay? And this was showing you that you can see the scale here. Most of the graphics are scale from 0 to 12 to 15. This is 30, 40. It's almost double. And the problem that was that these people living in these two places were smokers. So that is specific, thing they do is changing everything for everyone in the house. Okay. The thing is that when you move to a smaller city in the south, this is from Patagonia. This is Coyhaique. Coyhaique is a rural area in the south of Chile. I didn't show you this, but the overall level of contamination here between Chile and the USA is basically the same. So you could say, oh, it's not that bad, right? It's an urban area. In the US has a lot of really tight environmental laws comparing to Latin America. So if you have the same levels of pollution, it's not too bad. But if you go to a rural area, this is not the case. Chile is like 10 times more than the US compared to similar areas. This is Coyhaique, a very small town in Patagonia. And we're looking again into these compounds that are being emitted by wood burning. This is an interesting case because people living in the same house, staying indoors or not, they do have the same behavior. They look exactly the same. So these patterns here are not showing up anymore. The thing is that we believe is that wood fire and pollution coming from burning wood is so strong that it doesn't matter what you do. You're always exposed to the same thing in Coyhaique. Okay? And it's showing you a really high level of concentration, 10 times more than similar cities in the US. And this is a place where you don't have any industry nearby, you don't have any other emission sources, just fuel burning, just wood burning. And that brings us to a new concept that I found, and that is very useful to explain what's happening in Chile. Energy poverty is the lack of access to these affordable, reliable, and sustainable modern energy services. So people need to still be relying on wood, okay? And that translates into a lot more pollution than they should feel. This is something else that we use the wristbands for. We were looking for compounds that are classified as carcinogenic by these two organizations, and we found many of them in different cities in Chile. These two are from the north. This is Santiago. They look similar, except for a few compounds that you can find in Iquique, Tocopilla, but not in Santiago. Or the other way around, some things that you find in Santiago, but not in the other two. Makes sense, except for the fact that Santiago has 8 million people, Iquique has 200,000, and Tocopilla has 20,000. Why is this small town in the north having even more of these carcinogenic compounds comparing to the city of 8 million people? Is because here you have a industrial port, you have processing industries that are serving the mining companies from that area. These companies are located very close to where people live in Tocopilla. And we believe that is why they're feeling all this extra pollution compared to what they maybe should, right? Being 20,000 people living in one small town, they don't burn wood as in Coyhaique, because this is in the north, so they don't have a problem, but they still have some dangerous chemicals that are being in the local air, right? And the last thing I want to show you for this part is what we do as communication for the community, right? We are not showing chemical structures, we're not showing chemical names. We are showing this plot with more common names, and we give this report back to the people that participated in the study, and they could easily see where the problem of exposure is coming from. For example, coffee again, or smoking here. This person obviously is anonymous, you don't see the names of the people there, but they get this feedback, and that's why they keep working with us, right? So the key findings, some key findings for this first part, outdoor and indoor contaminants can be very different. Using only the official outdoor monitoring station for policy becomes tricky. It's not right to use just this one official monitoring station. Lifestyle plays a major role. Energy poverty translates into more contaminants. And these distributions are highly dependent on geographic locations. That is a big problem. And I say a big problem because when you go to these locations, everything changes because the chemicals that are being emitted are not the same. These are not organic chemicals anymore. These are inorganic. These are metals. So they won't absorb to the respect. They're killing our main gun that we have for this, right? So we decided to use a different approach. We went to this area. And why this area? Because you have Chuquicamata here. It's the largest copper mine, open pit copper mine in the world. And it's been working for over 100 years, extracting copper. And you also have a tailing ponds here, Talabre, largest in South America as well. And you see all these towns very close to these mines. The black dots are mines, and this is the tailings pond. And all these towns are supposed to be protected by the environmental law. So we wanted to see if they really don't feel any effect of the industry that is so close to them. We collected dust because, as I said, these are organic compounds. They're not absorbing to the wristband. They're not going to work with the other methods. So we decided to just go up there, go to the roofs and collect some of the dust that was deposited there. From roofs, from windows, and from local soils. And the thing is that we wanted to prove that whatever you find in the roofs is not coming from local soils, but from somewhere else, right? And these are the wind patterns here. I'm showing you this because that is the reason why we're focusing on these towns over here, because winds are coming from this area. And we know that because people told us, people living in that area told us. At 4 p.m. every day, we see the cloud of contamination coming to us. And we didn't believe that until we were there. And it's true. I mean, you can see that thing coming. So we sampled there, and we found that this is a very simplified version of the plot. If you want to see the real plot, please talk to me later. Mm-hmm. These are enrichment factors because we are not showing nominal concentrations because this area is in general very high in concentration of metals because that's why it's a mining area, right? Enrichment factors is comparing the background concentration to the concentration that we found on the roofs. So this is how much over that background area we found, right? And the colors are the amount of concentration, relative concentration. So you see that towns that are close to the emission sources, obviously they have relatively high enrichment factors, right? But what happens to this area here? And I'm showing you here the distance of the official statements from the company say that people living within this circle are entitled to compensation because of the environmental damage that could be done by the mining company, right? It's just here. But we found very high concentration in Cupo, right there. Have you ever heard of this town, Cupo, in the north? The Chileans, no. This is Cupo. We have 50 people living in this town, right? 3,500 meters in altitude, 120 kilometers away from Calama, from the main sources. Not the 10, 12 kilometers of this circle. We're talking about very, very far away and really high in altitude. And just 50 people living in there. They had no idea they were having this contamination coming every day. These are real pictures actually from Cupo. So that brings us to another concept that is related more to this kind of studies, right? Environmental justice. The fair and equitable distribution of environmental benefits, striving to eliminate disparities. Obviously, we are witnessing a very complex case here because you have very big, large mining operations in the area, and you have towns of 50 people that are not going to be heard in a court, for example, or if they complain to the local government, I don't think they're going to be lucky, you know? So we as chemists, we didn't stop there. We wanted to know where these metals are going to actually, because we know they're potentially being emitted from these two sources. And the class that I teach regularly in Chile is called biogeochemistry, and that's a class that is focusing specifically on this, knowing where compounds, chemical compounds are coming from and where they're going to. We need to know the whole cycle. So we needed to see where these metals are being accumulated, where they go. So the first thing we did was collect like 150 samples from this area. These are maps that are showing you mining operations. This is Talabre tailing pond. This is the city of Calama, and the towns are located in this area. The colors is the concentration of the metals in that specific area of the soils. And we found a lot more metals. I'm just showing you 4 of them. Zinc, obviously, no real correlation because zinc is a crustal element, it's present in the entire planet. So that makes sense. And this was just to prove the point that our methods are not showing us something weird. I mean, zinc is okay to look like that. Copper, for example, really high concentrations close to the copper mines, makes sense too, okay? This is weird. Lead is being centered in one point in the city of Calama, not in the mines. So just keep in mind that for later. I'm gonna show you a little bit more data here a little bit. These are relative concentrations, and as I said, this is a mining region, so this is not surprising at all. We were expecting something like that. Once they get into soils, what happens to them? And we wanted to test if these metals are able to get into biota, into trees, into agriculture. So we took samples from local trees, and yes, we found trees in the Atacama Desert. And the story is that these trees first are the same species. They're all the same trees, and they were planted 60 years ago by the Chilean president at the time as a gift to the people of the tree that we could take samples from the trunk. We didn't cut the tree. It's just a small piece of the trunk we used for analyzing the concentration of metals. And what we found is that whenever you go, you move on time here, right? From 1970 to 2020. And we compared that to the cycles of production, of copper production in Chile. And they really look similar. Actually, whenever you have a boom in production of copper, 2 years later, you have a spike in the concentration in the trees. So the things that we were finding in the previous slides, they're not new. They've been happening since 1970, right? And these people in these areas have been getting this extra amount of metals for many years. It's not a modern problem. It's coming from for a few years so far. And what else? What is the other possible destination of this dust, mining dust? Is getting into your houses, into indoor environments. We tested indoor school samples from the city of Calama. This is the city. And why we decided to go here? Because of this. We wanted to see what's going on with this distribution that was a little weird. And we found, we were very lucky to be working with the local government here because they gave us access to the entire public school system in the city. So we have around 70 samples in total of all the schools in the city. And this is expected copper concentrations very high from the copper mine, right? Because it's very close to the copper mine, I mean, it makes sense. We can't really explain the arsenic levels in this area. We don't really know what's causing that. And the lead is still very high in here. Okay, what is the possibility here? This might be coming from fossil fuels. We did isotopic analysis showing that the dust that we collected from these indoor environments is not coming from engine combustion. So we're sure it's not. We found that everything that you see outside and inside the schools is basically the same. That's why I have these box plots in here. No significant difference. So everything that is outside, it's being found inside as well. And it's not coming from vehicles. We believe it's coming from mining because we found this little guy. This is, it's right. This is a mineral form of copper chloride called tolbachite. And why is this interesting? Because that mineral form is only found in deep deposits, very underneath the ground. I mean, it's not a surface element. It's not a surface mineral that could be, a product of erosion. It's not that. This is coming from mining because they are the only ones digging this deep in the crust, right? The thing is that this mineral form should not be stable in a humid environment. Whenever tolbachite sees water, it dissolves. So the fact that we're finding this in these schools means that first, the environment is really dry, low humidity. That makes sense because we're in the Atacama Desert, the driest place on Earth. Okay, so that makes sense. The problem is that once you breathe these particles, your lungs are humid. So this mineral form is going to dissociate into copper and it's going to make it more toxic. So that finding was very interesting because we were kind of explaining the fact that mineral dust is extremely toxic comparing to other kinds of dust and comparing to natural erosion. Okay, so what happened with the lead? We went there again, a field trip, and we found that that little dot here that was showing you the highest concentrations of lead, it's actually a lead battery recycling plant. And it's the only recycling plant in the country that is serving the mining corporations in the area. So that makes sense. And that's why we see all these high concentrations of lead. If you want to compare that to the US averages or EPA guidelines, it's right here. So the concentrations we find are very, very high. And don't forget, these are indoor dust from schools. So are they affecting our children? This is the next steps. Just be carefully interpreting this data because it's a preliminary data. It's not a formal analysis yet. And I know these correlations might be a little not perfect, okay? But it's showing you that that specific school that was having the highest lead concentrations is also showing you the lowest scores in mathematics and in language standardized testing that they do in Chilean schools every year. So that school is right here, the lowest score and the highest concentration of lead. Is that correlated? Looks like, right? It makes sense. Lead is a very relevant metal in terms of human health. So that is where we are aiming for the future studies. This is one last comment regarding the green transition and global environmental justice. I believe it's often based on raw materials coming from the global south, still with the potential to increase environmental injustices already present in the extraction of oil and minerals. So the question is it really a green transition? We keep taking metals and minerals from the same areas. It could be further, complicating this reality of people living in this. As I said at the beginning, we work with people all the time. So they are aware of the results. They were with us when we were showing this in public. So they organized themselves using our papers, and they sued the state of Chile last year. This was in November 2025. I was part of that too. I was in court explaining the papers basically, and we'll see what that, how that ends. I mean, we still have a few months, I think, of discussion there, and we'll see how it goes. And the last set of key findings for the second part: metals require a different approach. Local knowledge was very important in this experiment, and we need to stay close to the community. Sample collection, communication of results, and just do not run away with the data. I mean, getting the data from them, they deserve to see the results and to see where this data analysis is going to. And mining is really complicated. I don't want to get involved into the usual discussion that there is, that is a big economic ingredient of Chile, 15% of the GDP, but it's still affecting these people. So what do we do? That's a big problem. But it is also an environmental justice problem. It's not just an economic problem. Okay. So the last thing I'm going to show you, just remind you what we do. We use chemistry as a tool to understand this distribution of contaminants. Our goal is to generate data that could be used for studies of environmental inequality, environmental justice, and using a lot less money, which is very important in Latin America. And we're always looking for new and exciting interdisciplinary collaborations. And with that, I would just want to mention all the people that collaborated with us, because we don't have all these fancy instruments and all this fancy technology, but we do have a lot of friends. Thank you for listening.
Yes. Thank you so much for this very rich talk, and I am thinking of the interdisciplinary collaborations that you mentioned at the end, because in terms of making, on the one hand, the data available and working with the notion of citizen scientists that you brought, I think narratives are very important, right? So I'm a literary scholar working in environmental humanities. So I wanted to ask you two things. I wanted to ask you because you showed us studies in Santiago, and I can talk about Santiago, but if we concentrate in the north, in Calama, there's a trope of the desert that is so important culturally, because culturally we have this metaphor of the desert as something that is empty. There's no people there, there's no life there, and you brought the opposite. But I wanted to ask you if in your work with the people in Calama, you have seen this trope coming up, the problem of how to explain what the desert is to people that don't live in the desert, yeah. Or if this is a friction, like if there's a discursive friction, if you will, of explaining desert to people in the desert or out of the desert.
Yeah, I mean, I can tell you that explaining these results in Santiago is always you feel a little bit of a tension there, because the first thing they say is that Chile is really lucky because they have these mineral deposits in places where no one lives. Yeah, there are a lot of people there. And knowing that as indigenous communities in this area, they are entitled to state protection, most of the people living there don't really know that. And to complicate things more, most of these people actually work for the mining company. Yes. So yeah, I mean, in Santiago, you have this tension of, showing people from the big urban center that north and south of Chile are still full of people and life and ecosystems. And I'm not showing anything about the frogs in the Alto Loa, right? Because that's another story in Patagonia as well. I mean, but they keep repeating themselves, but they're lucky because the mines are located in there and not close to Santiago.
Yeah.
That's the first problem. And then working with people from the north and showing them that we are not against mining per se, but we want to just have more data to how to do mining in a more responsible way was complicated because they saw us coming in and many of them were like, oh, you're the environmentalists.
Yes.
And yeah, explaining, no, I'm actually a chemist. I'm not just in data, right? But yeah, you feel this tension all the time because of the economic, ingredient of the problem.
Thank you.
Yes.
Thank you so much. I also learned so much from the talk. And I just want to make sure I understood some of the takeaways. One of the things you mentioned, or I wonder if, I think following up on Nat's question, my assumption coming into this is that things like mining, like the costs are concentrated in the communities that are very close or neighboring mining companies, but the benefits, like the capital benefits from the GDP growth, economic benefits from mining in general. But it sounds like that's not the case. Like it sounds like the finding that wind and different atmospheric conditions mean that no one is immune to the harm that.
Exactly.
So is that something that people are aware of? Is this something that your research is sort of making people, like, for better or worse, conscious of? That they should be concerned, even people in Santiago should be concerned with what's happening in a small community.
Yeah.
In north of Chile.
I think this map is showing you that because in the red circle here, it's the official narrative that most of the impacts are happening in here. So whenever you show that because of the winds, you can get this town really far away affected by the companies, and it is not ending there. I mean, you can easily have this transported to Bolivia and Argentina. I mean, you can have an international problem here. It's just that we don't have data for that yet. The thing is that bringing data into discussion, it gives you more space to, argue other topics. But already having this background that we're not in doubt that the environmental effects are being felt 120 kilometers away. I mean, that's not a question anymore. We have data proving that. So I think we try to build that discussion starting from that point and not asking, is the mining bad or having effects on the people? But already knowing that first part. I don't know if I'm explaining myself here, but we want to bring numbers into the discussion and not just leaving it to interpretation. Some things, they deserve to be clear with numbers and error bars and all that. And that's what we do.
And I guess, sorry, just follow-up question, is regulation, is this changing the way that people think about regulation and sort of environmental impact?
Well, this last thing that I showed is that actually, because the state of Chile is aware of the publications now and of the data.
Mm-hmm.
And I have to say that when we publish these papers, these are 3 papers in Calama about that distribution of contaminants. We send them to the Ministry of Environment. We send them to the state company, because that's another ingredient. The company that is, taking the copper from the ground is from the government of Chile. It's not private company. It's government, state company. And we send them, all of them, these papers, like, this is data that you could be interested in, and please use this data for something. They didn't really say anything, but once the community organized and they presented this case, then they called us. So I like to think that our data, our numbers are doing something to at least push the discussion, start the discussion. Yes, please.
Can you tell us more about the nature of that call?
I'm sorry.
The
Again?
nature of that call from the state after the community raised awareness of these findings.
Well,
They called you. What they said.
yeah, well, the first one to call us were the state company.
Yeah.
And they read the papers and they invited us to the area to see the industrial part that is not open for the public to see, of course. And they wanted to show us how they work in protecting our environment and At the very end, they said something like, please keep this in mind whenever you write another paper like that. We're doing our best to take care of the environment. And we said, okay, yeah, I mean, they're changing filters and changing technology. They are doing something. But we said we are scientists and this is our job, we're gonna keep doing this. So they haven't seen the last part because it's not published yet. But then whenever they presented this case in court, Chile has 3 environmental court laws, court of law in the north, center, and south. And I had to travel to the one in the north. And I accepted to participate in this, but not as a demanding part. I mean, I don't know how to say that. I don't know legal.
As an expert.
Yeah, just an expert witness. Yeah. That's what I did. And we explained the papers, and it was good. I think it was very educational for us too, because we needed to explain the papers and the findings in a more legal, kind of way. So being really careful with the statistics and error bars and significance levels and all that. We learned a lot. It never was something like aggressive or anything like that. I feel like everyone is reacting to this a little late, but they are aware of this and they're working with us. Yeah.
Can I just ask a follow-up to that briefly? Do you find that to be true of the private corporations that are also participants in this? Because one of the questions that master's students here in Central Latin American Studies are working on for an essay due today is the question of the role of the state in Latin America broadly. And this is conjecture, but I would imagine that the state was much more receptive in some way to your feedback than, let's say, a semi-unaccountable private.
I don't have experience on that in Chile, but I can tell you about my experience in Canada. Because when I was working in Canada, we did something similar, but with the oil companies in Alberta. And that was a different approach, because those are all private companies, and we were the federal government, controlling their pollution. They hated us. Really, they never collaborated with us because they had their own scientists, and they were funding their own research. And I think that the way we confronted ideas was in conferences. Yeah. They had one huge session about oil sands in Canada, and you see one of us, presenting results, and then one of them, and then one of us. So it was like that. It was sort of fighting, not in a bad way, but it was more confrontational. The state was more slower. First, it was very slow in responding, but then it's feeling more friendly towards us, inviting us and showing us the company and the site. So they seem more interested in the result and how to solve it. Yeah, but I haven't had any experience with the private companies in Chile.
Hi, first, thank you so much for this amazing presentation and for kind of making it easy to follow and understand.
Was it easy to follow?
It was very easy to follow and understand, and I also find it very inspiring to see for all of us how we can apply our findings to activism and sort of trying to make the change that we want to see in the world with our research. So I just wanted to say that because I thought that was very remarkable. My question was more about the concept of energy poverty, which I found very interesting, especially because I was thinking about the wood burning that you're talking about. There's a lot of indigenous rural communities, not only in Chile, but Latin America overall, use wood fire, and sometimes it's something very tied to cultural identities. So I'm kind of just wondering how are you guys thinking when you're labeling this as part of energy poverty, because I also feel like it has a very strong cultural component that some people maybe don't want to abandon or might have different connotations. I don't know if that makes sense, but yeah.
It makes sense. I mean, burning wood in the south of Chile is part of the culture. It's what they do in the morning and around 5 p.m. too. I mean, in the whole house, it's built around the kitchen, the wood fire kitchen. So it's a very important part of the house, and changing that, I don't think it's gonna be easy, and I don't know if we should push for that change. And again, we're getting data, we're showing, numbers, and changing that lifestyle and and the way they live every day. I don't think it's our goal, but for them to have a choice, because right now they don't have another way of heating their houses. Maybe if they do, they could reduce this exposure. And again, I'm not trying to be the scientists in the big city telling them how to live their lives. And that is a big mistake, I think. But just, putting numbers in a problem that was not very well known, and then trying to give options to people to move away from these high exposure scenarios. And wood burning is important in that area in the south. But if you go to Santiago, it's illegal. So all the combustion products and the pollution that I showed, it's not wood burning. It's gonna be something else, using cars. Yes, please.
Yeah, thank you for your presentation. My question is like methodological. So I think you said, or I understood that when you have like a lot of components, some sort of are dominant over the others, and it's difficult to have to identify the presence of all of them when, I don't know, you have something like wood smoke or that. So methodologically, how do you deal with that? Like this it kind of obscure also like the effects or the presence of some other stuff. How do you
I did my PhD on that specific part. My doctorate thesis was on that, developing methods to improve the detecting capabilities of an environmental analysis. And we started with one method that was showing you 10, 15 compounds at the same time. And when we started using this new technology and made some changes, we were able to see up to 600 in same run. And when I say we were able to detect and quantify, I mean that we're really sure that this signal is the compound. I mean, we have a high confidence, and we are not having mixed signals or anything like that. We can improve those 600 if we use different technology. But with the technology that I showed, 400, 500 is easy to spot. I mean, we don't have that problems anymore. The thing is that we need the instrument, and it costs like $1.5 million, and we don't have that amount of money in Latin America. And that's why we have Environment Canada working with us, or San Diego State University there. They have the instrument. So we work with them. Right.
Yeah, I had a question, kind of methodological, but also ethical. So I think it could be helpful for the students. So how difficult was at the beginning to engage with the communities?
Very.
And then, but can you like give more, explain,
Okay.
because, and also like, how do these communities see now that you are like talking with the state or with the government?
Yeah.
And then what recommendations would you give to other researchers that, because since this can become a hot topic or at least raise more awareness, other researchers are going to want to go, but researchers that are not as ethical perhaps as you were, so that would extract the data and then leave, and the community might feel that they are taken advantage of. And so, like, are you thinking maybe of writing some recommendations for other researchers to approach the communities in a certain way to ensure that you have this, like, I would say, the best practice in terms of engaging civil society in these kinds of projects?
I think there is a lot of literature on that, and I think our experience was not planned like this in the beginning, to be honest. We started talking with the community because they had an idea of monitoring schools and we said that we can develop low-cost sensors for classrooms, and they were interested in that, and that was many years ago with one of my collaborators. And after that, I mean, we started, knowing people and having this like network, basic network. But then if you want to move forward, you have to give something back to them. And we always send the data, talk to them. We were giving presentations, either, in the place or Zoom, whatever. We were always present with them and working with them, not just for the data part, but for the planning, right? Where do we take the samples from, for example? That's something we didn't decide. I mean, they decided with us. They were showing us, oh, this is the place where you can actually see the cloud of pollution coming. Okay, we're gonna put a sensor here, right? We're gonna put a collector here, and trying to work with them like that. At the beginning, it was hard because all of them had bad experiences with previous researchers, especially in that part of getting the data and running away. I mean, they never heard back from them. They didn't know if the data was published or what happened to it. And probably the researcher was really, in a good position now, associate professor and blah, blah, but they never talked back to the community. So we were avoiding that, but very slowly, growing that relationship slowly. And that, I mean, now is a lot different because they are in this legal process. And I also was clear with them at the beginning that I don't want to be part of the process just as an expert witness. I can be with you like that, but I don't want to, be on the first line of this process because I have a different, career. So, but they understood. I mean, we had such a good relationship so far, but they were okay with it. And when I went to the environmental court, I just gave my findings, not my opinion on the problem, just comment on the numbers, on the statistical approach, and that's it. And they're happy with it. So I think we're gonna keep working. We have a few other ideas to do in this community, one of them with Andres there. So we're gonna expand this knowledge, hopefully. Moving into biomonitoring, that's it.
That was a good question by Kimberly in the first row.
Thank you so much for your talk. I'm really wondering how you decided to center citizen science. I feel like a lot of interesting environmental projects use and highlight citizens going out and collecting data or samples. So what made the project one, use the wristbands, and how did you decide your sample size, the people going out, and then right now you answered the question about the schools, who gave you those recommendations and stuff. So really the involvement of the citizen scientists with the project, and if you would do it again, or you would have any other way to improve it or other methods.
Well, this is a change of paradigm in how you get samples for environmental chemistry. We decided not to use the traditional approach, high volume samplers or this expensive equipment and all that, because we wanted to see more compounds. We were not interested in the usual way of extracting air in a filter and then extracting the filter to see the chemicals. We were interested in how the chemistry is working with something that is in a natural environment, affected by winds, by rain, by showers, because people were wearing the wristband even when they shower, because we wanted to see that. I mean, if you take a shower, you remove some of the chemicals from your body, and that's also happening with the wristband. So it's just a different way of approaching the questions. And once you get into that, you realize you need a lot more samples. If you're not using a high-tech equipment, you need to cover that space, say, with many more samples. And when we decided to do Coyhaique, because that's one of the first things we did, we realized that it's very far away and we couldn't travel all the time. So we started talking to people there, and they were really excited to be part of this, and we started growing with that. So everything started on the way you approach questions, and we didn't want to use the traditional approach because I believe academia has that advantage that you can try things.
Yeah.
So,
Amazing, thank you.
I guess, Director.
Well, first of all, I'm fascinated and I congratulate you for your work, not only the data you obtained, but also your methods, the way you're thinking about science is really fascinating. And it's also such a key issue, the Southern Code. Mining is so much in the public debates that I really appreciate what you're doing. And I had a question and a request. The question is whether international courts have been involved in Chilean cases. And the other question is, you mentioned in passing that you had done work in Antarctica and that you could talk a little bit about it later. So I wondered if you could do that.
I don't know is the first answer, because I don't think there's much history in environmental, groups suing for the state for environmental protection. I don't know how to frame that, but I'm not aware of any previous case regarding those similar topics.
Yeah, there have been two cases in Argentina.
Okay.
One related to Riachuelo and the chemicals in Riachuelo. It's
Yeah.
called El Caso Mendoza, and then there's another one with agrotoxics, but that's probably not the state.
There is one in Chile regarding historical pollution sources in Arica in the north, because there was an import of mining waste from Sweden in the 80s. Yeah, I know.
And there's
They
also
did that.
probably sacrifice zones are international,
Yeah. But then they deposit this waste in one area in the city, and then the company, I think it went bankrupt in a couple of years, so they left everything there. And obviously it became a low income area and mostly with immigrants right now. I mean, you can see those cases, but there's a lot of studies in that we have data for that too. I didn't show any of it, but and showing that still 30, 40 years after, we can still see the signature of that pollution. And but I don't think that became a legal case. It's just research, like other research here and there, but not an organized one. So I think that's why we got this media coverage in this case, because this is one of the first, I believe, in this area. And I have to say that the other expert witness was the senator of the region, was myself, and he was the former mayor of the city. So yeah, that was weird. And regarding Antarctica, we wanted to show that our collection methods were working in extreme conditions. So we spent a couple months, 2 years ago over there. And it turns out that they're great working in under zero conditions. So we're hoping to get funding to go to Antarctica again next year.
And what's your question? What were the concerns?
That's also a nice question, because we were wondering if the emissions or the contamination, the pollution that you see in Antarctica is coming from local sources or is being transported by atmosphere. Why? Because we see a lot of tourism going to Antarctica right now, and we don't like that. And we wanted to show that February, which is the month where everyone goes in this luxury and very expensive cruise to Antarctica, is exactly the month where we have this big spike in pollution. We have a paper on that too, actually. And we showed that, and we have data for 2 years in a row now that is showing that especially February is especially polluted in Antarctica. And using the same methods. Because no, the fixed collector. Yeah, because remember, we're chemists, so we tend to try to get data from everywhere just to prove our point that our methods is working.
So I'm just curious, because you said also that there's the academia as a space for testing. If you show the testings that you have done for organic material in Santiago, but I wonder if you're ever going to try to do the metal testing, because like you have El Teniente, and El Teniente is historically such a big important copper mine.
Yes,
And
but it's an underground mine.
yes, but
That's
still.
the difference. Yeah, I mean, I'm not downgrading. I'm just saying that the emissions that we try to prove in Chuquicamata
Will be
are
different.
air emissions, right? Because it's an open pit mine.
Yeah.
El Teniente is an underground mine.
Yeah.
We're still wondering how to do that. But we will.
Let us know.
And it's not in Santiago, it's in Rancagua.
No, I know, but it's very
Kilometers.
close, right? So that's
Yeah.
what I'm thinking in terms of like how things travel and.
I think it's gonna be about sulfur dioxide in that
Uh-huh.
mine. Yeah, because they have a lot of sulfuric acid that's being produced as a byproduct of the mining.
Uh-huh.
And I think we're gonna try to catch them using that. Yeah.
I have
Well
a
detected.
No, go ahead,
No, I
That's
heard
good.
it.
That's okay, because I have this like closing comments / questions for thing. So get your questions in.
So I had one more question, as sort of a concerned person when you see some of these micro, like you started a conversation at the talk with mentioning microplastics, and I see the sort of all of the contaminants, and I don't necessarily know, like, oh, is it, like, which one's worse? You see that
Yeah.
there's variation.
You see, I never showed any chemical structure or anything. I'm just avoiding that. If you want more details, I have all the, yeah, toxicity and all
I
that.
know that I know how to make sense of it, but I'm curious as someone who's sort of interpreting and consuming information about these contaminants. You show that there's a difference in sort of even within the household, right?
Yeah.
There's a regional difference, but even within the household.
Yeah.
With the data that you have, is there any measure that we can see, like, what's household share of the variation versus regional share of the, or even just town share of the variation, or even seasonal share of the variation?
It is really hard because it depends on the region of the country. If you go to the south, everything is the same because the pollution from wood burning is so strong that it's covering everything. In Santiago, you see a lot of differences when people live close to the highway, for example, you see one spike. When you have a smoker in the house, you see huge spikes everywhere. So we can have recommendations for that. We haven't done that. I mean, other than the personal communication that we give back to the people, in which you can, I mean, we coded everything, right? But they know which one is their wristband, so they can see the groups. And then on the next page, we put a definition, basic definition of the group of chemicals and how to reduce that. I mean, we have done that, but the next thing we want to do, and that's why I'm here actually, we want to build a proposal for an intervention study in which we're going to be focusing on both sides, north and south, and installing filters, atmospheric filters, air filters inside the houses and see what the differences are in terms of pollution, chemistry, chemical pollutions, and also in terms of lung function, which is Andres' work. He just left. So that's in the future. So maybe in a few years, so we'll come back and show you that.
I think Andres just left to get a smoke. No. I had a comment and a question, but the comment is, I mean, congratulations for this amazing work again and for communicating it so clearly. We know that this is relevant to all of us, but it's different to also understand it, you know, and then you really did a beautiful job. I see also in our last talks that we have encountered these interdisciplinary problems. You know, there's like a thickness of interdisciplinarity here. Jimena mentioned environmental humanities. Again, there's also the legal angle. There is community perspectives. So it kind of like, you know, justifies being asked to collaborate with study. So,
Yeah.
so I'm super pleased. Then the rigor, yeah, it's just good things. Now, my questions are, I'm going to take you up on that graph where you showed your own confidence and ask two, you know, not, I wouldn't say personal questions, but personal-ish questions. The two questions are as follows. One is, how does your knowledge change how you live? I'm really interested.
All right.
As and
That's a question.
so I'm gonna drop the mic. And then the other is, you know, how do you get into this non-lucrative, right? Choice, because listen, I grew up in Bogota in the 90s, so dating myself, and my friends who would have an advanced chemical degree had the option of working for say DuPont, doing environmental activism, sure, or working for the cartels. Back in the day. They would hire people out from advanced chemistry degrees. My colleague was right. Yes. So, but it's a real predicament. You have these skills that make millionaires out of people. And I know that our students are thinking about careers. So these are big questions. So one is the how does knowledge translate into your life question, and the other is how did you choose this amazing career?
Well, the first answer will be, I have no idea, but that's a very interesting question. And, the fact that acknowledge that one of the things that you do on a daily basis is showing up in the registry like this. I mean, and it's showing the differences like this. This is huge. And I'm not really sure if I drink the spend coffee or what happened, right? Because I drink a lot of coffee, but that's a lot. And my experience when I saw these results, I was checking the numbers and I was like, no, this looks wrong. I mean, I'm gonna analyze this sample because we did everything like randomized. We don't really know which sample is from what person, right? So we connect that at the very end. But I remember seeing this sample, like, no, this looks wrong, run it again, and do it again, and 3 times, and it was like, no, this guy drinks a lot of coffee. And then we connected, and I was like, oh, and I feel so bad about it. I don't know if I changed the way I drink coffee, but at least I knew it already.
Yeah.
And I can relate to a few environmental laws in California, in this state. Because if you go to any restaurant that is serving burgers or grilled meat, you see one sign that says you can be exposed to dangerous chemicals by being in this place or something like that. I mean, I'm not sure if that is changing the way people eat, but at least they know. I mean, and I think knowing something is, and you were actually saying something similar before the talk, right? I mean, people
know their choices.
Yeah,
and they
their choices.
choose according to their knowledge.
But they have better knowledge now. So I believe even this information could help people, finding a better way to, I don't know, live their lives. And I'm not sure we're in the position of telling them what that means, but we can generate data to support that decision.
Yeah. And I'm sorry that I'm happy to say something and then run, but I think that's something that is really important in terms of this discussion is when you are analyzing pollutants and where you're looking at toxicity, people tend to have this reaction to look for something that is impolluted, right? And there's nothing that exists that is not, exposed to some or other substance, and we always live in that in-betweenness. There's no, because the thought of purity is so dangerous politically that we have to be careful about that system.
Yeah. I mean, the way some constitutions are phrased, saying that people have the right to live in a clean environment, it gives a space to a lot of interpretation. I mean, what is a clean environment? And it makes you, try to prove that this is toxic. And most of these are not going to be that toxic. It's just chemicals. I mean, chemicals are everywhere. Chemicals doesn't mean that they're bad. It's just showing you that we can actually see your lifestyle pattern in a chart, right? Because I didn't tell you this, but we found illicit drugs here too, and tea and chocolate and a lot of things. So it is just a way of understanding, and what people do with that information, out of my scope. And second question was,
I don't know, why not be a millionaire instead?
Well, I don't know. Well, I was trained as a chemist. I did analytical chemistry in grad school. My PhD was about improving analytical methods So a few oil companies approached at the end, but they wanted me to live in Kazakhstan or Middle East, and I was like, no. And then Environment Canada appeared in one conference that I told you about, and I felt like, you know, their mission was aligned with what I thought at the moment, of protecting the environment. And then they told me about the project, like using your PhD thesis in improving our control systems over the oil companies. I was like, sure, yeah, and living in Toronto, great. Yeah, I was there. And then Chile appeared, and I found that there's so many things to do in the country in Latin America. So I believe I could, you know, find my own way. Maybe that's the answer. Working on my own ideas and trying to find a personal way of solving questions. I don't know. It's not the best choice, it's just my choice.
Carlos, on that amazing notes, thank you very much.
Do we continue?
And stay tuned for our next events.
Thank you.
Good.